Okay, so today we're going to talk about our last chi-square test, and that is the chi-square test of independence. You'll see that this test is slightly different than our test of homogeneity and goodness of fit test, and that it has one additional condition, and the expected matrix is set up differently and is calculated differently. So as far as our conditions go, we still need counted data. Each expected cell count still needs to be greater than or equal to 5, and we want a random and independent sample as always. Now, our additional condition is that the total observations should be less than 10% of the population. And this really goes just to reinforce that independent sample. So those are our conditions. Next, we're going to talk about the expected matrix. So to find our expected matrix, we take the observed total or observed row total times the observed column total divided by the grand total. And I'm going to show you an example. So it says a 2017 Gallup poll asked college seniors whether they feel prepared for a career upon graduating with a degree in their desired field. The observed data is shown in the contingency table below. So we have our observed table over here on the left. So we can see that 30 people are graduating with a degree in science and math, 70 with liberal arts, 46 people said that yes, they feel prepared, 54 people said that no, they did not in total. So I'm going to fill in my totals because we do not expect those to change. And I'm going to show you how to calculate the expected cell counts for those that are graduating in science and math and feel prepared. So we know that if two variables are in fact independent, we should be able to take the probability of graduating with a science and math degree times the probability of feeling prepared and find that intersection of yes and science and math. So I'm going to take my row total, 30, times my column total, 46, and divide by that grand total. So what I would expect, 13.8 people to be graduating in science and math and feel prepared upon graduating. Remember with your expected, you do not round, just leave it as a decimal, that is perfectly fine. I'm now going to pause the video for a minute to fill in the rest of my expected. Also, if you do not already have your calculator out at this time, please make sure you get it. Okay, so here's the rest of my expected matrix. Notice that each column does add up to 46 or 54, and then each row adds up to 30 and 70. Okay, so now for our actual full-blown test. As always, we have usually 4 parts. So the first part being our null and our alternative hypothesis. So for my null hypothesis, I want to say that the college degree field and career preparation are independent. And then for my alternative, it would be college degree field and career preparation are not independent. Just like we never accept the null hypothesis or we never accept the alternative, we cannot prove for sure that they are dependent, but we do have reason to believe that they are not independent. So you want to be careful that you're not saying independent, dependent, that we're just using independent and then not independent. And I'm going to test this at the 5% level. So I should back up real quick. It does say calculate the chi-squared value and decide if there's sufficient evidence to refute the H-naught claim of independence. And that's what we just wrote out here. So then my second part of any hypothesis test are my conditions. So I'm going to take a minute to write out my conditions and show you how I would justify those. Okay, so going over our conditions. So the first one is counted data, and we are just talking about the number of people, so that would be counts. The second one is expected must be greater than or equal to 5. Well, in this case, our lowest was 13.8, so we're good to go there. The third is that we must have a random and independent sample. So in this case, we must assume that the random sample was taken, because I don't believe they told us if it was random or not. And then the fourth one, our total observations are less than 10% of the population. And I think it's safe to assume that 100 is less than 10% of all college students. So our third part of our hypothesis test is now our mechanics. So again, I'm going to take a moment to kind of start these, and then I'll walk you through them. Okay, so for mechanics, I have two things kind of started here. So I have the degrees of freedom and then the chi-square test statistic. For our degrees of freedom, for the test of independence, we take the number of rows minus 1 times the number of columns minus 1. So since this was a 2 by 2 matrix, I would take 2 minus 1 times 2 minus 1 to give me 1 degree of freedom. Then for my test statistics, remember this formula is on your formula sheet. So it's the sum of each observed minus the expected squared divided by the expected. So for example, going back to math, science, and yes, they feel prepared. So we observed 20 people in the math science department that felt prepared. We expected 13.8. So for my test statistic, I would start with 20 minus 13.8 squared divided by 13.8. Then I would do this for not prepared. So I observed 10 minus 16.2 squared divided by 16.2. Plus, this is where I would say you do not need to do this for each and every cell. I would like you to set it up, then I do plus, dot, 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 and then the final component. So if I'm working my way down, this would be liberal arts and does not feel prepared. So 44 minus 37.8 squared divided by 37.8. Okay, so at this time, I'm going to show you how to do this in your calculator. So in my TI calculator, I'm going to first, so what I need to do first is actually put the observed matrix in. So if you haven't dealt with matrix or matrices in a while, the matrice button is on the left-hand side, so it says matrix. Notice it's in blue, so I need to hit second, matrix. In order to enter in a matrix, we go to edit. So you need to select the size. So it's rows times columns, so a 2 by 2. And here I already have my observed in, so I would just put 20, 10, 26, and 44. At this point, I'm going to go to Stat, Test. I want to arrow all the way down to the bottom. So for chi-squared, notice we have two options. We have chi-square test and chi-squared goodness of fit test. We want the chi-square test. That's going to be our test of independence. So here you'll see observed matrix A, expected matrix B. Here's just a little trick for you. You actually do not need to put in the expected matrix. It's kind of neat because your calculator will automatically calculate it for you. And I'll show you this in just a minute. So because I put my observed in, which you do need that, I can go down to calculate. So I end up with chi-squared equals 7.369. My p-value is 0.0067, or sorry, 0.007 roughly, and then 1 degree of freedom. So that chi-square test that we are just calculating, we know that that turns out to be 7.369. And the probability that chi-squared is greater than 7.369 with 1 degree of freedom was 0.007. Now, like I was saying with your expected matrix, so if I go back into my matrices, and here's where your matrices will be stored. So I'm going to go down to B because that's where my calculator said they were going to store it, and just hit enter. That is actually your expected matrix. So this works really well if you're having to calculate a really large two-way contingency table, so there's a lot of cells. But keep in mind, you need to know how to calculate the expected, okay? That's a wonderful multiple choice question or kind of some of those quick questions that might come up. Okay, finally for our conclusion. So I'm going to take a minute to write out my conclusion and then I walk you through that. Okay, so I apologize, this is kind of squished in at the bottom here. But our fourth and final part of the hypothesis test is always our conclusion. So obviously, because we had such a large test statistic and a p-value of 0.007, so this is really, really small, smaller than any typical significance level or alpha level, I am going to reject H0. So I just said with a p-value less than alpha equals 0.05, p equals 0.007, I reject H naught. And now for the context. So I said that I have reason to believe that the degree field and career preparation are not independents. So I'm basically just restating my alternative, saying that I have reason to believe this. So there's one more example. I would like you to start the second example, and then I will show how to do that afterwards.